So in our last section, we talked about the two operations that can make a number bigger, and those two operations were multiplication and addition. But there's actually another operation that could be used to make a number bigger. And the operation that can be used to make a number bigger, we could also do, would be exponent, or the power operation. So we have three operations that can be used to make a number bigger. The one that is most impactful would be our power, or exponent. And the least impactful would be addition. So if I order them from the most impactful all the way down to the least impactful, it kind of gives me an order for me to follow when I'm doing my rules. Now let's take a look at that next property. So the power property looks a little something like this. How did they take the numbers 5 and 3 and get 15 from them? Well, what they did was they multiplied these exponents. So we could stand to reason that our power property would be that when I am taking the power of another power, using that power operation, I am going to multiply the exponents. So if we look back at our most impactful to least impactful, when we are taking a power of another power, we multiply the exponents. When we are taking multiplication of the bases, then we add the exponents. Let's work through a couple of problems. So we have a power raised to a power. Now I know that this is a power raised to a power and different from our product property, because in product property, each of the variables or each of the exponents had their own bases. And in power property, there's only going to be one base shared to both exponents. And we would read this as x to the 4th to the 6th power. So that means that the exponents are going to be multiplied. So my answer would be 24. I know that I'm going to multiply the bases because there's only one exponent. One base. So I'll multiply the exponents. There's only one base, so I'm going to multiply the exponents. And that gives me z to the 35th. Now the when in doubt, write it out works for power property too. If we look at this one, we had y to the 2nd power, which means we had y times y. And we wanted to cube it. We wanted to raise it to the 3rd power. So that meant I needed 3 of those. There's another y times y, and here's another y times y. How many total y's were there? There were 6. So you can always write it out for the power property as well. We're going to do a couple more examples. I know that this is power property because I have A raised to the 8th power, and that whole thing is raised to the 2nd power. Only one base visible. So I'm multiplying those exponents to get A to the 16th. I know that this has to be the product property because each of these exponents have their own base. So B to the 9th plus B to the 7th. Remember, when you're multiplying the bases, you add the exponents, and when you are raising a power to a power, you multiply the exponents. I'm multiplying the bases, so I'll add the exponents.